GCSE 9 to 1 maths, okay, looking at the back end of an Edexcel higher tier paper from the November 2022 exam series, paper 1, non-calculator paper. Okay, we're looking at some grade 8, 9 questions on the Edexcel paper. This question number 23. It says, here are the first 5 terms of a geometric sequence. Part A, work out the next term in the sequence. Well, the common difference, okay, it's not so obvious here. The common difference is actually, sorry, not difference, sorry, the common ratio. So the common ratio multiplier is actually 2 root 5. Okay, and the reason for that is because if I do 10 divided by root 5, okay, so I'm doing the second term divided by the first term, that will tell me what my multiplier will be. Now I'm going to rationalize the denominator here, so I'm going to multiply top and bottom by root 5. Okay, so taking my time with this. Sorry about my handwriting, guys, I apologize. Hopefully you can still read it. Okay, I'm going to get 10 root 5 on the top. On the bottom, I'm going to get just number 5. Okay, root 5 times root 5 is equal to 5. So this now simplifies, dividing top and bottom by 5, I get 2 root 5. Okay, so that's my common ratio. Sorry, not common difference, common ratio. Okay, so I'm multiplying by 2 root 5. So I'm going to multiply this by 2 root 5. Okay, so multiplying surds together. Okay, numbers go with numbers and surds go with surds. So 400 times 2 is going to be 800, and root 5 times root 5 is going to be 5. So it's 800 times 5, which gives me the answer of 4,000. So 4,000 is the answer for that question. Now that is a pretty nasty, I think, question, and I think it should be definitely worth more marks. But unfortunately, it is only actually worth 2 marks. But yeah, to go from the second term to the first term, I've divided by 2 root 5. So the common ratio, okay, if I multiply root 5 by 2 root 5, I get the answer of 10. Okay, this next one. The fourth term of a different geometric sequence is 5 root 2 over 4. The sixth term of the sequence is 5 root 2 over 8. Given that the terms of this sequence are all positive, work out the first term in the sequence. You must show you're working. Okay, so the fourth term is 5 root 2 over 4. And then I've got a gap. Then I've got 5 root 2 over 8. Okay, now the numerator of my fraction has not changed, so I'm multiplying by a fraction in this case. So 2 jumps, okay, represent 2. Okay, so from 4 to 8, I times that by 2. That's 2 jumps. So 2 jumps, okay, equal 2 as my multiplier. So 1 jump, okay, will equal 1. Okay, so it will equal 1 of that. Okay, so essentially I'm multiplying it by a quarter each time. Okay, so not a half, is half of a half. Okay, because from this to this I times it by a half, but I want half of a half, so I times it by a quarter. So the third term will be 5 root 2 over, okay, 16. Is that right? Sorry, 1 second, guys. So 2 jumps, sorry, is going to be 2, yeah, so it's a half. Okay. 1 second, guys. Yeah, I think I made a mistake here. So 2 jumps, it'll be a half. Okay. So 1 jump will be 1 quarter, a half of a half, which would be a quarter. But if I times 16 by a quarter, I don't get 8. So am I timesing it by 1 over root 2? Okay, so that might be right then. So I think I'm actually timesing it, yeah, by 1 over root 2 actually, rather than, which is obviously pretty nasty actually, yeah. But so to go from 4 to 8, okay, times it by half. But if I times it by root 2, okay, I'm going to have 4 root 2 there. And if I times this by root 2, or 1 over root 2, sorry, okay, then I'm going to get 4 times, so root 2 times root 2 would be 2 times by, yep, so sometimes it gets here, so it's a bit more than that's just here. So I'm timesing this here by 1 over root 2. Now that's not very obvious here, and sorry that I've not done it very well here, but, so I'm multiplying it by 1 over root 2 each time. So I'm going to divide this by 1 over root 2. So I'm essentially going to be multiplying by root 2 because I'm going backwards. Okay, so, but the issue here, guys, is the numerator hasn't changed though. And if I divide it by 1 over root 2, okay, so the second term I think is 5 root 2 over 2 root 2, if that's right. Okay, because 2 root 2 times root 2 gives me 4. Okay, so that'll be the second term. The term before that, okay, will just be, yeah, will just be 5 root 2 over 2. Okay, because if you times this by 1 over root 2, then I get 5 root 2 over 2 root 2, okay, which actually cancels, so it's actually 5 halves. So your answer, guys, your answer is 5 root 2 over 2. So sorry that I didn't actually explain that very well actually, but hopefully that makes a bit more sense now. So apologies, if I wasn't very clear about that. So that's my answer for that one, okay? So please, obviously, re-watch it if you need to, okay? But the scale factor multiplier, so the common ratio, I'm multiplying by 1 over root 2. Now that's not very obvious here, it's not very nice here, because it's geometric here, so like I'm essentially square rooting this here rather than dividing it by 2. Okay, so I get 1 over root 2, okay? So that is my common ratio. Okay, when you work backwards, your answer you get will be 5 root 2 over 2, okay? Because if I times this by 1 over root 2, then I get 5 root 2 over root 2 here, which obviously cancels, so it's just 5 halves. And if I times that by 1 over root 2, then I get 5 root 2 over 4. Okay, and then from there, that is actually now correct. Okay? So that, guys, is my final answer. So sorry for mentioning that question, but hoping that makes sense. Question 24. Here is a solid sphere and a solid cone. You've got a volume of a sphere, volume of a cone. All measurements are in centimeters. The volume of the sphere is equal to the volume of the cone, okay? With equal. Find the ratio of, so find R to H. Give your answer in its simplest form. So 4/3, okay, pi R cubed is equal to 1/3 pi R squared H, because that's telling me that the volumes of each other are equal to each other, okay? Okay, I can cancel the pi's, I can multiply by 3, so I get 4R cubed is equal to R squared H. Dividing both sides by R squared, I get 4R is equal to H. So R is equal to H over 4, or a quarter H. Okay, so that's the ratio for the H. So you have H over 4 to H. So you multiply both sides by 4. So you have H to 4H. Then divide both sides by H, you get 1 to 4. So 1 to 4 is your final answer, guys. And that's my ratio for R to H. Okay, so hopefully that makes sense. Okay. So these questions here are quite nasty questions. Okay? They will appear at the end of like a typical Edexcel paper, okay, or a typical AQA paper, or a typical OCR paper. So please revise your like geometric sequences, arithmetic sequences, quadratic sequences, okay, like volumes and surface area of like spheres and cones, okay. and practice writing things in terms of ratios of one another, and expressing stuff as a fraction if it's a ratio. Okay, but sorry that I messed up here. Obviously 23bx here, but hoping that makes sense. Okay, so 23bx here, just to be clear, the common ratio is 1 over root 2 or root 2 over 2. Okay, so either one. Okay, because that's the same. If you rationalize that, you get root 2 over 2. Okay, so your common ratio is either root 2 over 2 or 1 over root 2. But 1 over root 2 is a bit more easier to see. Okay, but hoping that makes sense. Okay, sorry if I'm actually waffling on there, but hoping that makes sense. Okay, again, any questions, any queries, put it in the comments below. Thank you so much for watching. Please like, share, and subscribe. Sorry, please like, subscribe, share, and comment. Follow me on TikTok, and I'll see you in the next video. Okay, bye for now. Take care. All the best.